What is information? When it builds. Based on Chapter 8 of George Kampis's Self-Modifying Systems in Biology and Cognitive Science, 1991. We follow George Kampis through machines that build themselves, through systems that grow their own rules, through structures that evolve from within. But now comes a subtler question, one you may think you already know the answer to. What is information? Not just packets of bits, not just zeros and ones, but what does information really mean inside a living, self-constructing system? In Chapter 8, Kampis challenges every definition we've taken for granted. This is information not as code, but as transformation. Let's tune into its signal. The classic view, disconnected and passive. Kampis opens the chapter by dissecting how information is commonly defined. He reviews the most famous and influential theory, Claude Shannon's information theory. Here, information is measured by its surprise value, its unpredictability. The more unlikely a message, the more information it carries. But here's the catch. Shannon's theory says nothing about what the message means. It's syntactic, not semantic. That's fine if you're transmitting radio signals or compressing files. But what if the message makes a cell divide? What if it makes a mind learn? In these cases, information isn't passive. It changes the system. And that, Kampis says, is where classical information theory falls short. 2. Information as system-relative construction. So what's the alternative? Kampis proposes that information must be understood as system-relative. It's not about signals arriving. It's about what happens to the system that receives them. In self-modifying systems, information is not stored like a file. It's generated through interaction. It transforms the system's internal structure. Let's take a biological example. When a molecule binds to a receptor, it might trigger a cascade. That cascade isn't just a result. It's a new configuration of the system itself. Information, here, doesn't travel, it emerges. 3. Semantic closure and functional meaning. Kampis goes further. He introduces the idea of semantic closure. This means a system interprets information based on its own evolving state. There's no external decoder. There's no predefined list of symbols. Instead, the meaning of a message is constructed within the system, and it might change as the system grows. In short, meaning is not assigned, it's built, and it only makes sense in context. For Kampis, this is what makes information alive. It's not about transmission. It's about construction and function inside a growing, adaptive system. 4. Information and component systems. Finally, Kampis returns to his foundational concept, the component system. In these systems, new components can produce new types of signals, and those signals can only be understood by the components that emerge after them. This creates a feedback loop. Structure creates function. Function interprets input. Input transforms structure. And in this loop, information is born. This is not a side effect of the system. This is the system. Conclusion, information is what builds you. So let's return to our question. What is information in a self-modifying world? Kampis answers with quiet clarity. It's not surprise. It's not compression. It's not even communication, really. Information is the internal process that transforms a system from what it was into what it can become. It's growth encoded. It's meaning produced, not received. And it is the living heart of every self-constructing system. In our next episode, we'll explore how these systems of meaning and growth begin to model, observe, and even anticipate the world they live in. Until then, stay sharp. Stay curious.